The figure you're looking at in front of you here is called a KenKen, and this is a 3x3 KenKen. It's the smallest KenKen that exists, and it has some nice rules. If you know how to play Sudoku, you're pretty much all set for KenKen because two of the three rules are exactly the same. And rule number one is, in the case of this particular KenKen, you're going to use the numbers 1, 2, and 3. And in a classroom, I always have my students write the numbers either on the top or the side or the bottom, so they can look at their possibilities, and it helps them visualize the possibilities and the relationships between the numbers. Now, if you look at the top row, you have three options here, three choices, and all three digits have to go in the top row here with no overlap. Same thing with every column. All three digits have to be there. So those two rules are exactly the same as Sudoku. The third rule is where it gets exciting in the math classroom. For instance, up in this particular area here, you'll notice there's a 3 and a plus. What that means is these two squares right here are called a cage. They're surrounded by a large black thick line. Those two numbers have to add up to 3. So in other words, the only two choices you have there are going to be 1 and 2. Unfortunately, at this point, we don't know where they go. So what I encourage kids to do is, when you have this situation, right on the border between those two squares, write the two possibilities as a reminder to themselves. And then when they get another clue, they'll be able to determine which of the numbers goes on the top and which one goes on the bottom. So those are the three rules. Now let's proceed to solve this. Now there are some nice things in this particular KenKen, some free ones. And I call this a free one. The only number that can go here is a 3 because it's a single square and the clue says 3. Now there's one other free one, which is right up here, and that's of course going to be a 1, so we'll go ahead and record that one. And now we can use our logical reasoning sense and figure out these two particular squares right here, because that square here can no longer be a 1 because we have a 1 right here. Therefore, this must be a 2, and underneath that must be the 1. And so we have this column all filled in. It must be a 1, 2, and a 3. Let's work over here. And we have the same sort of situation we had before, 3 plus. So these two particular squares here and here have to be 1 and 2. But this one has to be a 2 because up on the top is a 1. And you can't have a repeat. So we come back down here, fill this one right over here with the 1. And now some interesting things are happening here. We have all of the 1s. And notice that in every case, the 1s are in their own row and they're also in their own column. So let's finish this up. This one has to be a 3 because you have to have all three digits in each column. And now it only leaves us these two over here. If you look at this particular row, you have a 1 and a 3, which means this has to be a 2. And this one has to be a 3 for actually three reasons. You have to make sure that the top row has all three digits as well as the right-hand side column. And you also have to make sure that when you're looking at this particular cage right here, that all three numbers add up to 8. And you've got that.